Ladies and gentlemen, thank you for taking your time and listening to the next couple of minutes. What I would like to do now is to speak about a double rotor system with an in-between cooling coil and control system. The main goal is to have a very high precise control of humidity and temperature as good as possible, as economically as possible, to save what we all hear since a couple of years, to save energy, to save oil, to save gas, also to save money. Hot and humid areas. What is hot and humid areas? You may think of Asia, of the US, South, maybe of Africa. But more and more regions of the Earth are getting hot and humid. So it is very important to control the temperature. This is something we do since several decades. We know in winter we take heating, in summer we take cooling. So we know about the reasons and the hows when it comes to temperature. But what about humidity? Humidity is equally as important. Humidity is not only making us living, it's not only giving us the needed substance to remain alive and to stay alive. It also could kill us, to be very precise. So a control of humidity and temperature, both put together, is essential. Now, there are a few different ways on how you could enter the idea to find a solution. There is a sort of like an environmental approach, architectural approach, looking into some countries in the Arabian area. We can see that they are building the cities in a very special way. They are building houses in a very special way to have wind movement, to have shadow. So there are options in our architecture, in our environment that we can use to control heat and to control humidity. If this is not enough, we can use our classical stuff that we all know. We can use chillers, we can use heaters. Classical coils, they do exactly what we want. They cool down, they heat up. But it's a classical way without any intelligence into it. There is no energy saving, there is no energy recovery into it. And there is maybe something that we could call a technical solution-orientated way. What are the technical solutions that we need to deal with water, to deal with temperature in the way that we want to have it? Not paying too much of money, not having any losses, and being precise and simple in the same time. For today, I only want to focus on the last point, on the technical solutions. I'm not an architect, I cannot speak about environmental options. And as I am part of a group that is looking and focusing and forwarding into clever solutions for air conditionings, logically, I will not talk about mechanical solutions the old classical way. Today is going to be focused on the technical approach, how to do so. I'm going to show you here the idea of a double rotor system to enable you to deal with water and humidity in the same time. You get your target, you get whatever you would need for your process, for your room, for your people, in the most advanced and economic way. You have energy recovery done by rotors, and you have, this is the very important part, a rotating heat exchanger itself recovers energy in any way, latent, sensible, but it has to be controlled. If you don't control it, you don't know what happens afterwards. And I will start now with a very basic idea. We have a hot, humid area, and we want to deal with humidity and with temperature. We want to have a comfortable room to work in. The classical way, the old way, would be using a classical chiller and a heating system. You can see here the blue square is the symbol for the chilling or the chiller system. The idea is to go from 36 degrees, 45% RH, which is quite hot, quite humid, not very comfortable, makes you sweat even in the shadow. And we want to have something like 18 degrees and 7.4 grams inside the room. In such hot areas, you need to cool down the air that enters into the room below your target. because inside the room you got heavy loads, like human people, computers, machineries. Here you can see mechanical cooling only. We are cooling down to roughly 9 degrees Celsius in order to force water condensing at the chiller. And to get to the temperature, you need to reheat it again. You have your target, you have whatever you need in your room, but you pay a price. The price is roughly 170 kilowatts chilling energy or mechanical cooling energy. And you pay, again, roughly some 30 kilowatts on top just to get back in temperature. You have whatever you need in the least economic way. Nowadays, economical approaches are more and more important. I'm not talking about money as such. Everybody knows money is a rare good. But it's also being clever how to save our energy sources, how to save raw materials. It is the most simple and basic design. There's almost not really a big control strategy needed to get to there. And sorry to say that way, intelligence not really given. It's a very, very basic system. Let's add an intelligent idea into the system. Let's just add one very basic heat exchanger. Let's add a rotating heat exchanger afterwards, the very simple one, a pure, sensible working heat exchanger. The idea here at that picture, as you can imagine, we still cool down the air by using a chiller. So we still have the 170 kilowatts of pure waste energy. I call it waste energy because you will see afterwards, you don't need that much of energy. But what you have now already, by just putting one wheel inside, 28 kilowatts are going down to 0.37 kilowatts. And speaking about 370 watt heating power, that's neglectable. We don't really need to speak about it. And the auxiliary energy, and that is the important point to keep in mind, this wheel runs with an auxiliary drive at 180 watt. So you invest 180 watts to save 30 kilowatts. Sounds like a good idea, and it is. It is still a simple design, but the control strategy starts to be more intelligent. You take into consideration more than just one part and one component. The heating part logically almost falls away totally, so you don't even need to control that part. This is done by the heat exchanger itself. And you could call it the first slight way of adding intelligence into the system. And now I would like to get into the sorption rotor and a full-on unit. The first wheel is a total energy wheel dealing with temperature, sensible, and latent with water. The heating core, the chiller in between does the rest that still might be needed. And the second rotor is heating up again. So what happens here is by entering 36 degrees, just on the sorption wheel, a total energy wheel dealing with water, you get the 16.8 grams per kilo down to 10.3. So you have a system installed using, again, 180 watt, almost nothing in terms of auxiliary energy to make the wheel drive, to make it rotate. And you get out of the air just by nothing, just by putting it into the system. It's a no-brainer. You get down 6 grams. And these 6 grams per kilo, this is latent energy that the cooling coil does not need to supply, full stop. As a conclusion, this is the system, and that is, by the way, one of our today's problems. This system has a high COPEX and has a very low OPEX. But what is the decision taken today for most of the investors? It's CAPEX. OPEX is another part. It's another company. It's another partner. It's something else. I don't care. So everybody today is driven by the pure investment at the very first spot, at the very first step. That is CAPEX. And this system has the highest CAPEX for sure. You need to invest into 2 rotating systems. You need to invest into controls. Controls for temperature, controls for humidity. But as we all know, at the end of the day, an intelligent system, a clever system using clever ideas, being monitored and controlled the correct way, will save you money on the long run. And that is something that unfortunately often is forgotten. If you speak to bankers and to investors that are just looking for a best ROI in the shortest time, this system is going to die. You will not be able to convince that person to invest into that system. But if you tell the same person the banker who knows a little bit about finances, if you tell the same person how much money he can win, he can earn cash in his hand, in his bank account, if he starts to understand how much money you save and you earn afterwards, you will be able to convince people on using that system, because these are now the numbers that have to be considered. We had been starting by 170 kilowatts chilling energy that you need to get down to your dew point that you need for your absolute humidity. We are now on 57. This is less than 1/3. Looking into the price of energy, of electricity, of oil, of whatever energy raw material source we use, there is no time in the future when prices will be going downwards. There's only one direction for price in energy, and that is going to be upwards. Every day is getting more expensive. Next year, we're not going to pay the same as today. And the more you pay for energy, the better it is to invest in the first spot, in the first place, into a clever system, clever monitoring, clever analysis, and clever controls. So to conclude it together, it's quite simple. Doing nothing is very simple. Doing nothing is the most simple and basic way to live your life. It might be easy, but it might not be the best. There is an intermediate and advanced approach, if you would like. That is something that in German we would call it fauler Kompromiss. Sort of like a not a good compromise. But at least there is a little bit of energy saving inside. But the gold nugget in treating heat and water, the way that we feel comfortable, that the building is protected, that the product is protected, to save your sales. At the end of the day, it is the product that you sell that makes you earn money. It's not the building, it's not the air handling unit. The air handling unit is something that supports your process. And if you are able to secure your product and to sell your product to a given price, that is what gives you the money. And that is the reason why it is very, very clever to be clever in the first step. And that is to, unfortunately, invest a little bit more than if you do nothing, like in the basic line. But it's the same thing if we are thinking about our dinner. If we don't want to do anything, we open the fridge, we take a piece of bread, put some cheese on it, and that's done. It will give you energy. You will not starve, but it's not really nice. On the other side, you could do a barbecue grill long job and make a good brisket. It will be a lot better and juicy, and the quality simply is a lot better. Everybody understands that when it comes to food, when it comes to drinks, when it comes to something that we use every day and that we see, feel, understand. On an air handling unit, on the roof, nobody sees it. It's a black box. So you don't think about it. But it is worth thinking about clever systems, rotating heat exchanger, highest efficiencies, the least amount of space needed during installation, the least amount of auxiliary energy needed to make them run, and pair it with controls. So what you need for it is very simple. What do we need to make that system operate? We need two rotors, sensors, and a control logic. What do we need to monitor? What do we need to analyze to keep the system working as we want to have it? On the rotating heat exchangers, the parameters to control, to monitor, and to analyze are quite simple. It's the revolution speed, and that's it. Off humidity and off temperatures, these are results of the operation. You need to monitor them and you need to understand them, but you do not need to change them. The change, the manipulation of efficiency is done by revolution speed. But this is just the energy recovery part. You don't know how much energy it saves. You don't know how long you need to go on top until you have your target. Because it is a black box. You need to take a look inside. So you need controls. You need controls for dampers. You need controls for air volume. You need controls for bypasses. You need controls for temperature, for humidity. And when you have those data and those figures, you need to have a logic that can analyze these figures and these numbers and that can take a decision out of these numbers, and that can take the control of the unit. So it is a relatively autonomous product at the end. It is a black box still, but by using monitors, sensors, detectors, and analyzers, we can take a look inside the black box. You can see here some different components that can be controlled. You can see some different products that can be offered to control and to monitor. And if you would like to know more about controls, about sensors, detectors, humidification, drying, desiccant, temperature, you name it, we would be very happy to welcome you on our booth at Corel in Hall 5, stand 306 and 304. And we'll be happy welcoming you for an upcoming talk. Thank you very much for listening.